writing it, sir? Yeah, it is. Alrighty, so what are we doing today? What is an indefinite integral? And we're going to start with a 2 now. Okay, no calculators, no groups on this. Here, take one pencil down.
Oh, we're getting on worksheet?
Work on here, put your name on this, and collect it. I want to see what you did. Okay. Then we'll get into groups in a minute.
One, two, three, 4.
Yes. All right, so this is a part 1 question from 1998 on the BC exam, part 1A, number 15. What is the antiderivative of x cosine x? And I copied this. I did this from memory. My choices are a little different. Yeah, like E. Look at E.
Yeah,
None of the above. Yeah.
Oh.
No, you mean not.
None of the above. All right. Well, the correct choice is here and there, so you're okay. Don't worry about those choices. Just do the question. All right. Let's see what you get.
Well, we'll see which one's matched, and then I'll know which one's right.
Yes. They're due now. Read right now. So we have a read right now. And don't forget your view notate later, your screencast you can watch later. And then we're going to do a little classwork in groups in a minute. At part 2 question coming up. This is what we're doing right now, 98 BC 1A15. All right, how'd you do? You're doing partial elimination? Yes. How are you eliminating choices, though?
There's the derivative of cosine.
Aha. Good. Using the derivative. Right. Good idea. Maybe you want to show a little work on here? I like it. That's good. We don't actually know how to integrate this one, do we? No. Is this a definite or indefinite integral?
Indefinite.
Indefinite. How do you know? There's no limits of integration. Doesn't go from like 1 to 2, right? Okay. So, what if it had limits of integration? What would the answers look like? Numbers, areas, right? Okay, good. So, when do you get an area? What's definite integral? When do you get the plus C? What's an indefinite integral? Alrighty. Who thinks they got the answer? Want to show us on the board? Show us what you did. Alright. Go ahead. Guess lecture. There we go.
I just went through all the different options by differentiating each and see which one led me to x cosine x. So the first one obviously doesn't work because then x sine x, when you differentiate that, you just do the product rule, so it's x goes x plus sine x. So that doesn't work. But then for the second one, it's x sine x plus cos x.
You can just go to the right side.
Okay.
Go to the top right.
When you differentiate that, you do the product rule again, so you end up with this part. So x goes
First times derivative of the second, plus second times derivative of the first.
And then when you differentiate the second part, cosine x, that's just negative sin x. So then these two terms.
And you end up with the integrand. Nice. Good. So you don't have to answer this question by integrating. You can answer this question by differentiating. And so a number of you did that. Well, you see.
You could also
Okay. Huh?
integrate it by parts.
Yeah, there's a technique called integration by parts, which is sort of like a product rule. How do you integrate a product of function x and the function cosine x? We haven't talked about that yet. So your only recourse is the correct antiderivative. Its derivative is the integrand you started with, and that's what he came up with. If you differentiate this, you end up with what you started. Perfect, nice. Okay, put your name on it and hand it to the middle. Put your name on the sheet and hand it to the middle. I want to see how you did. What did you get right at? Yeah, no, that's fine. More than one way to skin a cat, that's fine. This is not a grade, this is just sample work. So how you doing? Sample student work.
I love those.
Alrighty. Next. Alright, so don't forget your homework today. Page 316, multiple 2. We'll be talking about indefinite and stuff like that. Alright, we did it part 1, let's do it part 2. Kindly consider the following. 88 AB6, let f be a differentiable function defined for all real numbers x with the following properties. F prime is given, and f prime of 1 is 6, and f double prime of 1 is 18. Stop. Can you figure out A and B?
Yeah.
Okay, go for it. Get your groups, get your boards, get your markers, get your groups, get your markers, get your erasers. Get your groups, go. Let's see. Find A and B. The question is eventually to find the function f. All right, scribes in the middle of each group, please, so everyone can see what you're doing. We need an orator, we need a scribe, we need a critic, we need an arbiter. The group is too big. All right, you can do like we usually do. Just try to be in the middle with the scribes. I tried.
PDF is already there.
Yeah, look it up on Edmodo. Go ahead.
So you know the integral of that is going to be
Okay. So we can find A with B, right, so B X is equal to 2AX plus B, right?
No, I'm not going to do that for you. Danny, did you solve it yet?
Yeah.
So you got to plug in. Yeah, you can plug in and then you find it. B is equal to 8 over 6.
Yeah, B is minus.
Those are the two values.
All you need right now.
So then,
You're trying to figure out what f was.
Right. Because F double prime is 3, and it's also 2A.
and
wow.
2a plus
Second
b
derivative.
equals 8.
First derivative is 2ax plus b. Second derivative is just 2a.
That looks like a 6. So now you just.
Oh,
Wait,
No, b equals 6 minus 8.
how do you know to put a plus b?
Because you're using this one.
It equals it's where this equals 1. So when this is 1, it's just. Yeah, it's just 8. Good job, guys.
Guys, show your work. I want to see what you're doing to get A and B.
Plus bx. And
All you're doing is using what's on the board. You don't need anything else yet.
of 1 though. Both of those are 1.
Yeah.
So a
This is an
plus
AB6. This was
b
sort of
equals
difficult for the
6.
AB students that they didn't prompt too much or prompted you.
And
At this point, you want to find A and B first.
2a plus b equals 18.
Right, just use the first two givens. All you need right now.
What?
Those
Oh,
givens, right there. Your, what is it, I and II?
And then,
oh, so one of them has to be negative.
yeah. Okay, so then b minus
That's not
a
a
equals 6. I mean,
No,
That's-
b
I
equals
mean,
a
yeah.
minus 6 minus a.
Oh, no, we can just, yeah, B. Well, that's what you need. What'd you get?
And if you plug in 1 for x, I mean 1 for
Yeah,
one. Chelsea, if you plug in 1 for x,
so a is equal
Show your work, guys. You can show your boards. We're going to present.
Oh, that makes sense. Yeah.
and then 1 for x.
Yeah.
Guys, help each other out.
Oh, hi. You have to talk. Okay, so now what we do.
Don't tell me every single step, just the first step. What'd you do first? Anybody? What'd you do first? Anybody? You got the second derivative, right? What was it?
Yay!
2ax plus b. Okay. That's your first step. Don't integrate, differentiate. Just like the first step.
And then just plug it into.
Eventually, we've got to get everything. So right now, just figure out A and B.
Is that the goal of the problem, to find A and B?
Yeah. Well, yeah.
Then I guess we just.
All right, is everyone done with A and B? Did you get an answer?
yeah.
Okay, what was A? 12. What was B? -6. Okay. Who's going to present? Get this right? Who's the orator? All right. All right. So, all right, we're going to present the solution over here. Let's see it. All right, so put it up high so everyone can see it. And Noel has to like kneel or something. Get a little lower, Noel. Okay. All right, explain.
All right, here are the 3 givens. That the I, and I.
Okay.
So we found the second derivative by 2ax plus b, and then we did simultaneous equations since we knew these 2 parts. So we had f prime of 1 is equal to a plus b equals 6, because f prime of 1 equals 6, and when you plug in 1 here, the x's, the coefficients of a and b are both 1. With double prime, it's equal to 18, so 2ax plus b equals 18. Again, it's x is, that's when x is 1. So that's 2a plus b equals 18. Then we found b in terms of a with the f prime equation and plugged that into the f double prime equation.
Substitution method. Okay, good.
Substitution, yeah. And then that gave us a plus 6 equals 18, and a equals 12. And the only way that can work is, or if you just plug a back into this, you get b equals -6.
Okay, good. All right, thank you. Good. Everyone agree? Anyone disagree? Anyone got a question, comment, problem? We're good? Okay, up here. I did the same thing. I found second derivative. I plugged in 1 for x. Wherever I see x, I put a 1. Wherever I see x, I put a 1. Now f double prime is 18, and f at 1, and f prime at 1 is 6. I didn't do substitution. Guess what I did? I did elimination. I did subtract. So if you subtract, that what you did was perfect. I'm just showing another way. If you subtract, what happens to the b's? And you get A right away. Isn't that nice? I like it. Okay, then how do you get B? Plug it back in. If A is 12, B has to be negative 6. Negative 6. Ah. Okay, so let's continue with the rest of this question. Where'd it go? There it goes. Now that we know that the definite integral, this is a definite integral because we've got an area, 18, from 1 to 2, the definite integral is 18. Can you figure out the whole function? All right, so let's use that information. All right, you can erase the first part and continue. We got this far. We got that A is 12 and B is 6, negative 6. All right, this is what you gotta do. Use that information to get F. All right, so part A, we got that A was 12 and B was negative 6. Now can you use that to get F?
8.
That's 30. That's 32.
You're gonna use both. That's good. Now use the third given.
And then when you subtract the 2, the D will cancel out.
When do you get a plus C?
And this is a
When you
Yeah.
differentiate an
Yeah.
indefinite
So then
integral.
you just
Are you
plug in
doing
the
that
2 and
now?
since this is a constant,
How
not
do you
being
get F from F
variable
prime?
affected. Yeah.
That's what we did.
How do you get F from F prime?
Anti-differentiate.
Anti-differentiated, right. So this is an indefinite integral. There are no bounds, right?
Yeah.
So you're going to get a plus C. Do it. To say that the answer is simply the antiderivative of 12x squared minus 6x without a plus C is incomplete. Remember, when you anti-differentiate, you don't get a unique answer. The plus C could be anything.
Wait, no. Why don't we?
Yeah, I do. Now you got to figure out C. There's another given. There's another given. Let's see, what is it? Don't forget, another given. The area under the curve, bounded by the curve of f, and the x-axis from 1 to 2 for x is 18 square units.
1, 2 equal to 18.
So if we plugged in an F of
yeah,
You got it. What's your final answer?
except that you need to plus
Now
D,
this is going to equal what?
but then there's a plus D.
All
Why
right.
is there a plus D? It's a definite integral. There's only a plus C when it's an indefinite. They give us bounds.
Notice I'm using the indefinite integral now, but I'm going to use the
yeah,
definite
but what is
integral in a
that
minute.
coming off of it?
So what you get so far? What's the answer to this? It's not really? Yeah, why not? I'm integrating f prime. What do you get? What do you get? Do it.
4x cubed minus 3.
That's not you want that's I just did.
Okay. Did everyone get that far? I think you did. I saw it. All right. So how do you resolve the C? How do you figure out what C is?
Do the definite integral.
Use the definite integral they gave you. The area from 1 to 2 is 18. Notice the area under F. This is our F. Figure out C.
I can't read that.
No, you have to enter it again.
Can you just plug it in?
You're gonna get the
Did you integrate it?
Huh?
Under what?
You wanted a bigger D?
Alright.
Yeah, you messed up.
That's supposed to be the one.
You got your answer? Yes. 10 equals 10 equals C?
When you anti-differentiate here, do you need another plus C or a plus D or something? Do you need it? Definite integrals, that's going to cancel. You don't need it. You got, what'd you get for C? 10. What'd you get for C? 10. 10? Okay. What'd you get for C?
Yeah, we did it. We did it.
All right. I'm getting a vote for C equals 10. Does that sound good?
Yes.
No, no yet? Okay, okay. We're going to go over in 1 second. All right, stop work. Let's see how you did. Who can take it from here? Let's see. I like this group. This solution here. All right, who's the scribe? Who's holding it up? All right, come here. Everything's seated. Nice. Who's the big mouth? Eduardo. Hold it up high. All right, here we go. So from that point on.
From that point?
Yeah.
Oh yeah. Okay, that's just the indefinite integral, and you have to find the means what the function is. You have to find C first. So you find that area from 1 to 2. Okay, so you.
So what's the antiderivative?
So you got x to the 4th minus x cubed plus c
Plus C.
plus cx.
Yeah. So x to the 4th. Okay, you can stay over there. X to the 4th. What?
Minus x cubed.
Minus x cubed plus
cx.
cx. Evaluated from 1 to 2 is 18. I'm just keeping track of this for YouTube. Go ahead.
And then solve for c.
Solve for C. All right. What you do?
Plug in 2, plug in 1, and then subtract.
All right. So you plugged in 2. What do you got? 16 minus 8 plus 2c. Then you plug in 1 and you subtract. So you get 1 minus 1 plus c is an equation for c. And so what happens?
The 1 on that side cancel.
The ones that are gone. Okay, good.
And then combine, so that's 8 plus 2c equals 18.
So 8 plus 2c minus this other c.
Is 18.
Okay. And
And then 8 plus c is 18, so c is 10.
c is 10.
And then you
Okay.
plug that into the other thing.
Right, don't forget to restate your answer. You're not done unless you state the final answer. The final answer is what is f? And f of x is?
4x cubed minus
Okay, very nice. Thank you. Okay. All right. Now, have a seat. Now, you know how sometimes we have filth about stuff? Where people take a recognizable tune and change up the words and make it sort of funny about math or science or something else, whatever. Guess what? You're the filth. Yes, you ready? You're the filth today. There's a song about this.
We're not ready.
Yeah, you is. Where'd my song go?
Where? Phil, I don't know. I can't learn words.
I know, they're right here. You're gonna sing.
Oh, no, just work on the back of that. This is a trick.
This is just the question.
You're trying to
This is the answer. There's more than one way to write up the answer, you know?
Can we do this on the AP in song form?
Sure, go for it.
I know you show us all those funny symbols, but I truly.
Right, we don't need any of those funny symbols, right? None.
In song form.
There you go. Alrighty, so. Everybody got one? All right, we're going to sing this together. You ready?
Yes.
All right, this is our chief reader, Rosenstein. Rosenstein was the chief reader for AP exams for like 20 years. He was like Really, really, really tough. You left out one little thing, poof, you lost 9 points. Okay, it's over. Remember this 9 points on the previous one? Okay. This song was written by Dan Kennedy. Dan Kennedy is the author of your textbook, but when he wrote this way back when, 1988, he was just starting out. Nobody knew who the heck he was. He was a junior reader. He was not the chief reader, he was a junior reader. And he wrote this song because he was so upset about all the points that he had to take off people making silly mistakes. Oh gosh, here we go. All right, so this is sung to the tune of My Darling Clementine. How does that go? Where's the actual one? Okay. All right. So, are you ready? On 3. 1, 2, 3. Fearlessly, dirty beater, Archie Reader, Rosenstein. You're a hero. You gave 0 to a kid who was 9. In a classroom in Topeka on the 13th day of May. At the class of Mrs. Bentley for their 18th judgment day. After months of AP homework, Betty Sue was well prepared. She moved quickly through the problems, never nervous, never scared. AP6 was tough for some, but Betty Sue was feeling fine. As she smiled me with her answer, she was sure she had a 9. Then the tests were wrapped and bundled and were sent to EGS, where the group of expert graders would do justice, more or less. In the world of mathematics, sometimes things are meant to be. So alas, at George's briefing, Betty Sue was sample G. All the readers at the briefing gave her 9s with pleasure when they could see she had 4x cubed minus 3x plus 10. Stop.
That's what we just did.
Is that what we got?
Yeah.
That's what we got, right? Okay. Alrighty. Just saying. Alright, where are we? Okay. George was wincing with displeasure, and his head just gently shook. Then he sighed, that's not what I had, so let's take a closer look. Alright, stop. How many points can you get on free response question? 9 points, right? There's 6 of them, so max of 54 points. Part 2, max of 54 points in part 1. They scale it? Okay. In the 3rd line, she has F prime where she wants to integrate. Wait, hold it. Stop. Where's the error? What did we do right that she did wrong?
She wrote F.
She put an F prime here.
Because it is a prime.
This is F prime. This is the antiderivative. Oh, bad. Bad, Betty Sue, bad. Okay. All right. So, in the 3rd line, she has F prime where she wants to integrate.
And she never quite recruits this, so she can't get more than 8.
In the 4th line, she miscopies, and a 12 becomes an 11. What?
I'll admit that's just a pity, but her 8 just fell to 7.
Now she sees that A's 11, but her A's and B's don't mix.
So she changes B's and matches, that's too bad, she's down to 6.
Right, stop. Somewhere along the line,
Alright, yeah, that's not okay.
she mixes this up, makes this an 11, and then changes it back to 12 later on for no reason. Or it's, I don't know. Somehow the A's and the B's don't work out right. Oh, this 12 maybe. This 12. Ah. So she got an 11 here. And then she plugged that back in. Guess what she got? If she put 11 in here, -5. Oh. But then they don't work in the first equation, so she fudges something. Oh God, don't do that. All right. All right, where are we? Then she puts those terms together for a function to derive. Alright, so plus becomes a minus, she changes the sign somewhere, whatever. Okay. Then she integrates quite nicely, but we got the kid once more. For C is clearly missing, so her 5 is down to 4. The next line, by some magic, she is solving for a C. But she never justifies it, so we drop her square to 3. If you closely check her limits, when the end goes through, you will see she has it backwards, so now she gets the 1 and 2. Alright, stop there for 1 second. What did she do wrong?
She just
So
wanted to.
somehow she flipped these around, which would be the opposite of 18, right? I don't know, she got, it's testing conditions under pressure, you do crazy things, don't do that. All right, so we're down to 2. Now we're error, if consistent, could not yield the constant 10. If she puts it all together, this poor girl can still get 1. Oh my goodness. You can lose all 9 points, even though you had the right answer, but doing silly steps, messing things up. It happens under time pressure. How do you avoid this?
You practice.
Practice, practice, practice. How you get the Carnegie Hall? Practice, practice. Okay. Somehow she figured out that the B was wrong. She fudged it. Then I don't know. Somehow she ended up with a 10. It happened. Did 2 wrongs make a right?
Yeah, usually.
Okay. All right. Let's check some of this stuff. Let's go back to the first question. Can we check this with our TI inspired CX graphic calculator, computer algebra system? Yes, we can. So how about if we ask for the indefinite code right on your calculator? Everyone got a calculator? Someone on the calculator, please? All right, here we go. So how do you do it? You tell me. What are we gonna do?
I say,
Well, let's start with the new document. New document. And 1. And menu. And 4. 4. And 3. All right, now are there limits of integration? So skip that part. It always does this to me. Hang on. Okay, so just go over here and you write x cosine x, wasn't it? X cosine x, right? We got choice B, didn't we? All right, so let's see. So x times the cosine of x, I'm going to put an explicit multiply here just in case, sometimes it's a problem. All right, trig, cosine, enter. And with respect to x, close the cosine. Well, of x with respect to x goes here. And let's see what our calculator says. Is that what we got? Let's see, we got
we did it.
We got choice B. X times sine x was cosine x plus c. X times sine x was cosine x plus c. X times sine x was cosine x plus n. Well, the calculator's a little lazy there. It's equals. Times. Yeah, if you don't put the times in here, it doesn't recognize cosine as a function. It thinks you're writing x cosine as a function. Is the name of the function. Be careful. You need the explicit multiply. Or conversely, what if we took the answer and did what you did with it? Then how'd you do this problem? You differentiated it, and then hopefully you got that, right? So we differentiated x sine x was cosine x. All right, let's show that. So what do I do to get that derivative? All right, well, yeah. Menu, calculus, derivative. Okay, with respect to x. And then it's, what was it? There it is, it's this thing, right? I'm going to write it the way it's on the answer sheet. X times, do the times symbol, sine x. And what was it, plus cosine?
Yeah.
Plus cosine x. Cosine. Whoops, too many.
Was this on the BC part or the AB part?
This was a part 1A BC, no calculus. And we got x cosine x. Now be careful, there's a problem with this. Remember that antiderivatives are not unique. What does that mean?
They have a plus C.
The plus c could be different, right? So when you have a plus c, that's an infinite family of solutions. And when you figure out the c, you figured out the one curve that you want, right? What's worse here, it didn't happen here, but this happens a lot. If you anti-differentiate or differentiate trigonometric functions, you can get all kinds of weird answers depending on all kinds of different trig identities.
Oh, yeah.
So you may get a different answer that doesn't look the same, but it really is. Because what does the plus c mean? If I say my antiderivative was x squared plus c, what's the difference between x squared plus c and x squared plus 2 if you graph it?
You don't know what C is.
Say I told you the c is 1. Say in one question x squared plus 1, c is 1. And then another example, x squared plus 2, c is 2. If you graph those two solutions, how do they look? One's shifted. So they don't even look the same, they're shifted, but what is the same? The derivatives, the slopes of the tangent lines along the curve, right? So if you got a weird answer here, and you graphed it compared to this, it would look like a vertical shift, otherwise it would not be correct. Okay? All right, that's our point today. So, when do you have an indefinite integral? When do you know it's an indefinite integral? When there aren't limits of integration. When you have limits of integration, what do you get? A number or an area. When you don't have limits of integration, don't forget the plus C. Okay, erase, clean up, return, we're done. Thank you.